Let's do one more example. Specifically, let's do one where the function is not a polynomial. Consider the function f of x is natural log of x on the interval from 1 to 11. Find the c in the interval which satisfies the mean value theorem. From 1 to 11, the natural log of x function is differentiable and continuous. So the mean value theorem is going to work on this interval. The natural log is differentiable and continuous anytime we're above 0. All right. At 0, there's a bad spot. When you try to do natural log of 0, you get an error. Doesn't work in the domain. Same thing with negatives. We don't want negatives in the natural log. But as long as x values are positive, and in this interval they are positive, then the mean value theorem can be applied. The average rate of change, like always, is the change in y values divided by the change in x values. In this case, that is natural log, or excuse me, f of 11 minus f of 1 divided by 11 minus 1, which is what I was saying earlier, natural log of 11 minus natural log of 1 divided by 10. Natural log of 1 is 0. So we get natural log of 11 divided by 10 as the average rate of change. You could round this to a couple of decimal places if you'd like, but I am not going to at this point. Now, the derivative of natural log we know is 1 over x. We've seen that in previous sections. So if I want the x value whose derivative is natural log of 11 divided by 10, I simply need to place 1 over x equal to natural log of 11 over 10, and then solve for x. You can either cross multiply or you can take reciprocals. But it's fairly easy to see that x has to be 10 divided by natural log of 11, which is approximately 10 divided by natural log of 11 is approximately 4.17. Most likely in Moodle, it'll ask you to plug in your answer being rounded to a couple of decimal places. Be careful that you don't round this to a couple of decimal places before, because then that would throw off your answer. This example shows us that we can find the C in the mean value theorem for lots and lots of different functions, not just polynomials. You could do this with trig functions. We see we can do this with natural log. We could see we could, if you wanted to, do this with exponential functions. You could do this with rational functions. So long as the function is continuous and differentiable on the interval we're looking at, we can apply the mean value theorem. Now, the natural question that comes up is, what use is the mean value theorem? Why would we look at that? Well, there is some practical use in the mean value theorem, but the practical uses aren't as important as when the mean value theorem comes up in other contexts. So a lot of situations in calculus have this nice result, and in the process of finding the nice result, you have to use the mean value theorem. So while the mean value theorem in and of itself, it has some practical uses, but not a ton of practical uses, the concept of the mean value theorem is really important as an underpinning of a lot of other calculus concepts. So that's why we look at that.